is another input from this multiplexer. And the other input of this multiplexer is the jump address. What is jump address? Jump address, the 26 bits coming from the instruction, and the 4 bits of PC coming here, which will form the most significant 4 bits. And these 26 bits multiplied by 4 actually shift left 2. So we have 28 bits coming here, 4 bits coming here. The 32 bits is formed coming here. If it is a jump instruction, jump is 1. This control signal is 1. And this 1 coming here, and it means that in this multiplexer, the 1 input, which is the jump address, is selected, and the output of this multiplexer goes to PC. The next PC would be the jump address. Okay, so this is, and you see in the jump instruction, we don't have anything to do with the register file. We don't have anything to do with the ALU. We don't have anything to do with the data memory. Just instruction comes, jump address calculated, not calculated, just concatenated. 4 bits from PC, 2 zeros, they are concatenated, and the address will be calculated. You see, data path is very simple. Okay, so this was the last instruction that we have talked about. Okay, any questions? We finished. The single cycle CPU or processor implementation is finished. And you now have a very good view of the processor. There are things that we could discuss now and leave the rest for the next course, the next advanced course. As you could see here, there are different instructions. Add our format, load, going to the store, branch, jump. There were different instructions. And as I showed you, they uses different parts of the data path. For example, it seems that jump is very small. It's using just this concatenation. And it seems that jump would be very fast. The jump address would be available very fast. So this is fast. But for example, let's see another instruction. This is, what was that? Let's go to branch. For example, this is branch. Branch, again, we have ALU in the past. We have register file in the past. So they are taking times. Each one of them is taking times. And then the result goes to multiplexer. So we have almost 2 components in our path. The multiplexer has a very small delay, so I don't look at them. The sign extent is just repeating the last bit, so it doesn't take time. But register file, ALU, they do something, so they take time. So I look at them. So it is 2 components. But let's go to, for example, R-type instruction. R-type instruction, register file is inactive, so it takes time until the register is coming out. Then we have calculation on ALU. So again, we have something in ALU. It is like a branch. And then we don't have memory, and that's it. So it has 2 elements working and making the delay until the next PC would become available and everything has been settled, done.